It's Ethan Teaches Maths, and today we're going to finish question 7 of exercise 3G of Stats Mechanics Year 2, and we're going to do part C. Now part C is the hypothesis testing aspect of this, so strap in and let's get started. So we're told that European water rats, so this is completely different from part A and B. It's completely different, basically different question. We have a sample of 15 water rats is taken, and the sample mean mass is found to be 875 grams. Fine. So they're normally distributed with a standard deviation. So it's going to be n grams, which is going to refer to this n, and we're going to say it's normally distributed using another n. It's confusing, I know, but it's okay. And it's going to have parameters mu for mean, and the standard deviation is 85. We're going to square it because the actual parameters is mu and variance. So the mean and this variance, not the standard deviation. So you always see it as the standard deviation squared, which is the variance. Okay, little point, but it's important. So we're told that a random sample of 15 water rats is taken, and the sample mean mass is found to be 875 grams. Cool. Alright, so we need a 10% level of significance, and we're testing whether the mean mass of all water rats is different from 860 grams. Now, I haven't worked this question out before. You're going to see my own thought process, and you're going to see exactly how I would approach this in an exam. So without further ado, let's get started. So what I'm going to do, I'm going to have my sample, which is going to be represented as n bar, and that's going to be the same mean, but the standard deviation is going to be divided by 15, because this isn't the whole population, this is a subset of the population. And it's going to be, this is the variance, that's the standard deviation. You have to square root it. So it's very clear, it's 85 squared over 15. And we're going to square root it to get the standard deviation. So let me make that even more clear. So sigma squared is equal to 85 squared over 15. So sigma is the square root of 85 over 15, 85 squared over 15, which is equal to the square root of, well, just 85 over the square root of 15. Fantastic. That was just the preliminary working out that we just need to do. So what is mu? That is the question. And they've given us basically, two means. They've given us the mean which they observed from the sample, and they've given us the mean of they're telling us that this mean here, 860. So remember, hypothesis testing, the whole premise of it is that you have a null hypothesis, which you assume to be true, and you have an alternative hypothesis, which is true if your null hypothesis is proved to be wrong. So in this case, you have to think to yourself, okay, what are we assuming to be correct? And right now, what we are assuming is that the mean is 860. Right? We don't care about what we're going to observe, we just care right now, we think that it's going to be 860. And the alternative is going to be different from 860. So that should be screaming out to you here, a two-tailed test. Why? Because it's different. It could be less than, it could be greater than. So you have to check both tails, or work out both critical regions, or you can just work out a probability of one side, and I'll show you that now. So if I draw a bell-shaped curve, so normal distribution, that will be 860. This is going to be n. Cool. So we're doing it at 10% level of significance. So remember, we have to split that level of significance either side, 5% either side, so 5% this side and 5% the other side. So this is 5%, which of course is 0.05. Similarly, the upper tail, 0.05 as well. Now we don't have to calculate the critical regions here. It's being nice, but if we did, then we get C1 on the left and C2 on the right. In this case, we're basically going to check if 875, where that is 875 there, is 875 there, and if 875 is here, it's going to be critical because that's in the region, and if 875 is outside the region, so it's here, well, it's not critical. You have to remember, like, if you're doing an experiment and someone comes along and says, all right, you're wrong, you can't just say, okay, I'm wrong, right? You have to be statistically significant that you are wrong, and the fact that and the level of statistical significance is a level of significance. In this case, is 10%. So if the probability which we get is going to be, in this case, bigger than 5% because it's a two-tailed test, then we don't care. Bigger than 5%, it's not significant. We don't care. If it's less than 5% or equal to 5%, we do care. And we're going to reject. So let me show you. Let me do the calculation. So we're going to do the probability of, so it's found to be 875. So this one's easy. It's not asking for critical regions. Just me n is bigger than 875. We're going to calculate that on our calculator. It's not going to be n. It's going to be n bar. And remember, the mean here is 860. That's what we're putting in our calculator as the mean, because that's the one we're assuming is correct. So n bar is bigger than 875. Going to the normal CD in my calculator, typing it all in, I get 0.24715. Now this is of course bigger than the level of significance, which is 5%. So actually 875 is somewhere over here. Now the fact that that probability is quite large means we're okay. Our null hypothesis is correct. It's not different. The mean isn't going to be different from 860 grams. The mean is going to have to be significantly bigger than 875 to get C2. Let's work that out just for fun. So what would that be? It would be the probability that n bar is bigger than C2 is 0.05. That would be, so what would C2 be? I'm actually going to work this out live whilst recording this. So I'm going to go to my distribution mode, normal CD. My lower is going to be my C2, but we don't know that. So what am I going to do? I'm going to work out this using my inverse normal. See, you get to see me work through it and my thinking during the video. So the inverse normal is option 3. The area I'm going to use is going to be 0.95. Why is that the area? Why aren't I going to use 0.05? Because the inverse normal gives everything less than or equal to. The inverse normal will give me everything here, right? Which is important. So that I'm going to type in 0.95 sigma, or I know sigma. It's 85 divided by the square root of 15. I worked that out previously, and my mean value is 860. So I put that in my calculator, and I get something quite interesting. I get C2 is equal to 896.099. And just so you know what I'm typing in, I have area is 0.95, sigma is the square root of, or 85 divided by the square root of 15, and mu is 860. So that's what I'm typing in the inverse normal function of my calculator. Any questions, leave it in the comments below. But this is pretty formulaic. It's not hard to mess up. The only bit which may be hard to mess up is making sure that number is correct, that it's less than or equal to. So it's to the left of the value which you're calculating. Oh yeah, and that gives me 896.09. Whatever. Okay, so that means this C2 value here, this C2 value is 896. So for our mean to be wrong, so the mean to be different from 860 at the 10% level of significance, you're going to have a rat, which is a pretty big rat, I assume, bigger than 896 grams. And obviously the value which we calculated, or they gave us, was 875. That's the observed value. So clearly the observed value is less than the critical value. So it's not in the region, right? It is not in this region here. It's not significant. So I've shown you two different ways to do it. It's completely up to you how you would want to do it in the exam. Both are valid, both are fine. So we would just say a concluding sentence. I'm not going to write it down, saying, I'll write this bit down. So do not reject H0, and then you do have to write down the concluding sentence, literally just parroting the question, saying this bit: the mean mass of all water rats is not different from 860 grams, because there's insufficient evidence to suggest that. Now, if it was different significance level, then it would be different, but in A-level maths, they give you the significance level, and you just have to work it out. Okay, well, I hope that helps. Be sure to check out part B and A, or A and B, if you want to learn more about how the inverse normal function works, and part B, binomial distributions, and the difference between the discrete and continuous distribution. That's all there on my YouTube channel. And if you want any more tips and tricks for A-level math, check out my website, ethanteachesmath.com, and there's loads of great content on that website, and you can even get private tuition from me if you want. Okay, I'll leave it there.